Okay, so we are doing part 2, 4.3, vertical and horizontal translations. So here in part 2, we are going to take a look at horizontal translations. Okay, so take notes. This is 4.3, part 2. Okay, so horizontal. Last time we looked at vertical translations, so now we're going to take a look at horizontal shifts. Okay, so this occurs when we are adding or subtracting to the angle. Last time with the vertical translation, that happens when we're adding or subtracting to the actual trig function. So like 1 plus sine, right? So this horizontal translations happens when we're adding or subtracting to the angle. Okay, so it might look something like this. Again, we are going to focus on just sine and cosine, but the whole idea transfers over to the other trig functions, which we will look at in the next section. Okay, so so now you are adding or subtracting here with the angle. Okay, so and again, just like before when we were multiplying with the angle, whenever you do stuff to the angle, it's going to change your endpoints for when you have one cycle. Okay, so so the same thing here. So we're still going to do the same thing. We're going to solve the angle here between 0 and 2 pi. Okay, so again, 0 to 2 pi that's usually where we have one full cycle of your basic sine and cosine graph, right? So here you're basically going to take whatever the angle is. In this case, it's going to be like x plus some number. And you're going to solve that between 0 and 2 pi. Okay, so let's take a look at an example. So let's go ahead and graph y equals sine x plus pi over 2 for one cycle. So again, normally we get one cycle between 0 and 2 pi, but because we're messing around with the angle here, the 0 to 2 pi is going to change. You might remember, you don't have to copy this down. This is just to help you refresh your memory. Do you remember doing something like this with parent functions? So maybe you have something like this, plus 2, right? This is your parabola, and it was shifted up 2 units, and this here would mean it would shift right 3 units. Okay, so same thing here. So here, this is going to shift, I should mention that, I guess, up here. This is going to shift the graph, the basic graph of sine x. It's going to shift it to the left pi over 2 units. Okay, so when it comes to graphing, we just normally do this to find the new endpoints, but you might get some questions in the homework asking you, okay, well, how is this going to shift? So here, let me just put a little note here. So it shifts k units. Okay, so let's do this. K units to the left. And this is if k is positive. Okay. K units right if k is negative. Okay. All right, so here, so if they ask you about shifting, this is going to be pi over 2 units to the left. Okay. If you're going to graph, okay, so you can kind of look at it two ways, and hopefully you'll see both of them happening when you do the graph. Okay, so if they ask you just about shifting, it's just pi over 2 units to the left. If you have to graph this, then we have new endpoints. Okay, and again, normally we have one cycle from 0 to 2 pi. But again, because we are messing with that angle, we have to solve for x and figure out what our new endpoints are. So here I have to subtract pi over 2 from all three. Okay. And that will give me negative pi over 2 on the left end. And over here, that would be 3 pi over 2 on the right end. Okay. So we see here now our graph is shifting to pi over 2 units to the left, which is why now our graph doesn't start at 0. It starts at negative pi over 2. Okay, so let's make sure we don't start at 0. We start at negative pi over 2. Okay, so negative pi over 2 and 3 pi over 2. Okay. Okay, and this is sine? Yes. Okay, so you can think of this as, here, let me put my 1 and negative 1. Okay, so we know that for sine, we have 0 on the endpoints and halfway in between. So halfway in between, we go 1, and then here. So halfway between. If you are ever curious, okay, well, what is that? What is that? How do I know that's halfway between? What is halfway between? You could always just take the average of your endpoints. You find average by adding and dividing by 2. Okay, so here it's pi over 2. Okay, and then we know that halfway between here is 1, and halfway between here is negative 1. Okay, so here is our graph. Okay, sine of x plus pi over 2. Okay, so I kind of skipped the whole, okay, let me start with the parent function and then shift it. I don't do that when I graph the trig functions. What I do is I just find the new endpoints and then plot my standard graph there. Okay, so it's kind of like, again, changing the backdrop of where you graph it. Okay, so whenever you mess with the angle, you're going to change the backdrop of where you're graphing this. So instead of going from 0 to 2 pi, we're changing the backdrop to negative pi over 2, 3 pi over 2. Okay. All right, let's, and again, if you're trying to figure out where halfway is between two things, like if you were like, oh, I didn't know that was pi over 2, how do you know that? Okay, so I said take the average of your endpoints. That's how you find the middle. That's, average, right? You add up your numbers and divide by however many numbers you're adding. Here we're just trying to find the average between your endpoints. So you just add them, 3 pi over 2 plus negative pi over 2, and then divide by 2, and you get this. Okay, here. 3 pi over 2 plus negative pi over 2. And then once you have that, you divide by 2, right? Okay, so that becomes 3 minus 1 is 2 pi over 2 divided by 2. And so that becomes pi divided by 2. And that becomes pi times 1, the reciprocal. So that's just pi over 2. So that's how you can get the middle. If you want to find out what the middle is between here and here, you could add pi over 2 and negative pi over 2 and then divide by 2. If you want to find the middle between here and here, you could add these two numbers and divide by 2. Okay? All right, so let's try another one. Let's graph y equals cosine x minus pi over 6 for 1 cycle. Okay, I'm going to erase this. So it doesn't look so cluttered. Okay. All right, so again, if we look at this from a shifting perspective, then this is going to shift to the right because it's negative, to the right, pi over 6. If we're going to look at this from a graphing perspective, we're going to get new endpoints. And so we need to solve. We know we get 1 full cycle of cosine between 0 and 2 pi, but because we're messing around with the angle, our endpoints will change. Okay, so add pi over 6 to all 3 parts. Okay, and we get pi over 6 over here. So we're not going to start our graph at 0 anymore. We're going to start it at pi over 6. And in the middle, we have x. And then over here, what is that? 13, 6, 12, 13, pi over 6. Okay, so this is where we're going to have one cosine graph, that interesting looking U shape. So we're going to get it not between 0 and 2 pi anymore, but we're going to get that shape from pi over 6 to 13 pi over 6. Okay? Pi over 6, 13 pi over 6. Okay? And we know we get 1 here and 1 here. And halfway in between, we get -1. Okay, what is halfway in between? So we learned how to find halfway between by doing the average. So let's do the average. We add up the numbers and we divide by 2. Okay, so we get 14 pi over 6 divided by 2. This is like 7 thirds divided by 2. So then we do 7 pi over 3 times 1/2. So that's 7 pi over 6. Okay, so if you're trying to find, if you want to label your axes, you can. Okay, all right, and then halfway here is 0, halfway here is 0. So this would be my graph. Let me do that a little bit better. Okay, so that would be your graph. Okay. Let's see. Let's see if you can try this one here. Let's go ahead and graph y equals sine x plus 2 pi over 3. Okay, and tell me what's happening in terms of shifts, and tell me what's happening in terms of your graph, okay? And let's just graph this for one cycle, okay? Again, I'm going to erase this, okay? So go ahead and click on the pause button and give this one a try, and come back and see if you get the same thing. Okay, so in terms of shifting, this is going to shift 2 pi over 3 to the left. And in terms of the graph, we're going to get new endpoints, so we will solve for them. Okay. I'm just covering these two concepts because some of the problems in the homework just asks you for the shift. Okay, and that's very easy just to look at. Okay, but then some problems ask you to graph, and so this method, this process here is just going to remain consistent whenever you mess with the angle. So we looked at setting this between 0 and 2 pi back when you had like y equals sine 3x, right? And we just put the 3x in between there and solve for our new endpoints. And now we're looking at it in with x plus some number like 2 pi over 3. You just put that in between. And in the next units, when it becomes even more complicated, so like maybe you get like 3x minus pi, the process is still the same. You would put the 3x minus pi in there. We're not looking at these type of problems just yet, but we will. And so that's why I introduced this method here, and I kind of stay with it for all of the units, even if it would be just as easy to graph the original sine and then shift it. Okay. All right. So x plus 2 pi over 3. Okay. So I'm going to subtract 2 pi over 3 to find out where my new endpoints are. So we're not going to get a sine graph from 0 to 2 pi. We're going to get it from negative 2 pi over 3 to 4 pi over 3. Okay. All right, so let's go ahead and graph this. So negative 2 pi over 3 and 4 pi over 3. Okay. And if you are trying to figure out the middle, okay, so again, you could always add your endpoints together to find the middle and divide by 2. Okay, so 4 minus 2, 2 pi over 3 divided by 2. So that's just like saying 2 pi over 3 times 1/2. And so we get pi over 3. So that would be right here, pi over 3. Okay, so we have, this is sine, correct? Yes, I believe so. Okay, so we get 0 on the endpoints and in the middle. And then halfway between here and here, we get 1. And halfway between here and here is right there. And then halfway between here and here is negative 1. Okay, so halfway between here and here is right there. And again, if you want to know this exact location on the x-axis, you could always add these together and divide by 2. Okay, and that would be 5 pi over 6. Okay. All right, but this is all you need. And that would be our graph. Okay, so hopefully you got that. Check your endpoints and make sure you're at 1 and negative 1. Okay. All right, so that is it for horizontal translations. If you have any questions, make sure you text me or email me or take advantage of the tutors.